Okay, so how many Polish words do you know? Bobber. Everybody knows bobber. Yes? You know bobber? We won't say the other word because, yes, we are polite. Yes, we are polite. But I can say in Polish, Grzegorz Brzęczyszczykiewicz, which makes me, yes, you have applause. Almost nobody can say it. From Szczęszewo-Szyce. Yes. Exactly. So really, really happy that Piotr is back to J Prime, this time without a doctor's, uniform, or what was this?
Sorry, is the mic? Okay,
Yeah.
the mic is. It's the lab coat for the crazy scientist. Actually,
Yes, crazy scientist,
if
crazy
you insist, I mean, it's not
Yes,
iron.
applause. He made it.
Okay.
He brought it.
If you
Yes.
insist,
Please.
just for you.
Just for us. Okay, thank you very much. Now you look like you should look. I mean, like how I remember.
Like a crazy hairstyle stuff.
Exactly.
Okay.
Yes, really, really happy that Piotr is back. He's a gardener himself, and he loves streams. And as I see, maybe he loves hunting, because I see his talk. Yes, we have good attitude to the animals. Anyway, I'm really happy that Piotr is back to J Prime. His talks are always awesome. And Piotr, thank you for coming. And the stage is yours. Make us very happy.
Thank you for inviting me. Well, I would say that, just to comment on what Mitya said, is the hunting is like this. Okay, I paid $20, okay? So I needed to get it back. So I asked a few months ago the almighty AI to generate this. So as you can see, we are like digital hunters, right? We are hunting for in this digital stream for what? For readability, for performance, and such stuff, right? So this is the idea. No animals have been harmed when this presentation was prepared or given. Yes, I'm not gonna lie, it's great to be again in Sofia. Somehow the city feels like really cozy to me. This is me. If you fancy to follow me in social media, I work as a developer advocate for Elastic. I'm also Java champion, Test Containers champion, and from time to time I write something to softwaregarden.dev, which is my personal blog post. We have to go through this again. Who's doing Java for a living? Okay, sorry, the opposite one. That would be easier. Who's not doing Java for a living? Wow, there are still people. Nice. Okay, and this was the easy one. Now the embarrassing one. Who has Java 24 in production? Yeah, exactly. Well, chances are if you're running the latest Elasticsearch, fun fact, I work for Elastic, right? You are, or you might be running Java 24 in production without you knowing. Okay, Java 21? 17? 11? Okay, the embarrassing 8. Don't be shy. They're recording me, not you. Okay. Voting with right hand? Voting with left hand? Cool, we're done. Java 6? Okay, I brought some Elastic swag for you, okay? We don't have a booth, unfortunately, so please come and grab some stickers and something. For you, I have like a special, webcam blocker. Please come after the talk, right? I'll reserve one for you, just kind of like a compensation, right? I'm sorry, I'm really, okay. Yes. Some say that Java 6 is pronounced Kotlin, but okay, never mind. Little warning, right? When I'm stressed, and I mean, you are very lovely folks, but I still might be stressed, right? I like slip words, say funny things, so it's on me. By the way, also, you know it better than I do. Never talk, never trust talking heads on the internet, right? So verify on your own. It's a human thing to make a mistake. So, little agenda for today. Prologue, 3 parts, the what, the how, and the why at the beginning, and an epilogue, okay? So, the prologue. I remember last year there was really someone really good at math somewhere in here, I don't know, sitting more or less where Gunnar is today. So what happened 4,075 days ago? Anyone? Java what? Java 5. No, not Java 5. Close. Warmer. Monday, okay. It could have been Monday, I don't know, I didn't check, sorry. It was Java 8, right? It was Java 8. And what did Java 8 bring us? Lambdas, right? The lambda expressions, and this is really the cornerstone of streams. Can you imagine writing strings without lambdas, only with anonymous classes? Doable. Easy? No bueno, right? Okay, so what is a stream? A quick recap, because there was still like people like with Java 6 or not Java at all. I'm sorry. Yeah, you volunteered for this stand-up, sorry. So what a stream consists of? A source, right? This can be a collection. Usually it's a collection, a splitterator. Then we have any number of intermediate operations, right? And then we have a terminal operation. And until we execute the terminal operation, right, nothing happens. So it's unlike the reactive streams, they are not push-driven, but by pull-driven, I shall say, right? And these are the intermediate operations introduced in Java 8, maybe not all of them, right? So I guess we are all familiar with filter, map, right? Maybe flatMap or map flatten should be called, like distinct. Who's using pick in their production code? Okay, please stop. All right, please stop. Unless you really, really have to use it for debugging, but then, I mean, we have to ask Anton or Mari. They have like a clever ways of debugging streams, right? Peak is really inviting side effects. We don't want side effects, okay? There are, of course, like terminal operations, and in theory, we could just go, for example, with one, let's say reduce, and we could implement everything else, right? So these others are kind of like helper methods, okay? And there was more. Apparently, there was more in Java 9. What we had was take while and drop while. In Java 16, we had these few, right, joining the gang. And then we had more terminal operations, or to be precise, just one, if I'm not mistaken. In Java 16, we had this to-list, right, which creates, what does it create, this method? Someone shouted unmodifiable list. That's a very good question. I'll put a swag aside for you, okay? I don't see you, but come back to me after the talk. Yes, exactly. It's unmodifiable list. Hence, there was debate, should this be called to list? Actually, there was more ways, right, to terminate your stream, because what happened is that we had more collectors, right, in Java 9, filtering and flat mapping. In Java 12, there was this very nice teeing, just like the T command. If you want to have like one stream and in one pass collect using two collectors, you can just tee the results to them. And since this is binary, you can construct any tree and use in practice any number of collectors, right? What also happened in the ecosystem, Grzegorz Piwowarek, not Brzęczysztykiewicz, but Piwowarek, right, and his friends created these parallel collectors, right, so you can use them. And don't lie to me if you have this utils class, and I'm pretty sure you have this utils class in your project, right? It's like this drawer of shame, right? Everyone has this drawer of shame in their apartment, and this is the drawer of shame of our project, right? Doesn't fit anywhere, utils it goes. Yes, I know. So the first part, the why, okay? Who's using streams? Yeah, I would say pretty much everyone who's like writing Java, exactly, right? But I said, what are the problems connected to that? So this will be the stream for like the first few demos. It's in Polish, right? Mitya's gone, but like I would nudge him to read this. Anyway, this is like a countdown, right? So in English, you have like ini, mini, mini, mo. If the children want to play hide and seek, in Polish, you have ene, due, rike, fake, torba, borba, ósme, smake, and so on, right? So this, we will turn this into a stream of strings, right? Just individual words, all right? And by the way, this is, if you are still not Java 15 or further, this is a text block, right? How to create nice text. Okay. And now the business requirement is, right, the product owners or whoever came like and told us, we have the following requirement for the customer. For each length, we need to get one word representing this length from this stream, right? So let's say for the length of 1, we will have, there's only one candidate, which is this I, or E, as we call it in Polish, right? For 2, we have nothing. For 3, this could be like eus, or ene, or due, and so the story goes, right? So, and we want just like the bag or set of words, and for each length, just one representative, okay? How would you implement this? Let's say I want to recruit you. How would you implement this? Ask ChatGPT. Okay. Clever. Okay. Yeah, map, goodbye, okay. Yeah, exactly. Yeah. See, I would say there are countless ways to solve this, right? At least 7. Okay, how about this approach? We can go this, actually I should have this in the code because in code we trust. So yeah, this is the stream, right? Let's see if this demo runs. It does, yeah, and this is the result. See, so we got Torba, Rike, Cosmateus, I, and Morele. Cool. So how does it work then? Let's go here, right, and this is it. So we go collecting and then. So first we go, see we created stream here, and then we have to go to map. So this would be like we map, the key mapper would be mapping by the length, right? Then we just go idem per idem, so it's like word to word. And then this is a new feature, by the way, in Java 21 or 22. This just basically means ignore, right? So if we have an existing word and a new word, new candidate of the same length, we just skip it, right? And then, because it's the end then, we have to go hash set and map values, and this is what we got. This is the result, right? And I just printed it. Now, the question is, what if there was like a reversed like order? First, you have seen this code, and I would need to, and I would ask you, what business purpose does it solve? Exactly, right? So that's the problem. That is the problem, right? So this code is, oopsies, did we lose the signal? Again, like, okay, oh, maybe I shouldn't touch the cable. Okay, it's protection and, okay, all right. Never mind, yes. If we need to reuse this, right, because we can reuse this, we can go something like this. So we can actually create a collector consisting of, and maybe this is more readable, right? So we have a map. If the length is absent, we put the word. Then we like merge 2 of these, like if it's running in parallel, right? And this is what we return. So we return a hash set of the values from this map, right? So we can just reuse it or have this assigned to a field or something like this. Now, there's another business requirement. We need to lowercase them all. We need to have all these words in lowercase. So how do we do that? Map, yes, okay, map is one approach, yes, or we can go something like this. We can go something like that. So see, I created this unique length collector, right? And again, I'm going collecting and then I'm just mapping them here, right? As you said, string to uppercase. Who said map? I will have a swag for you, right? Just show up later. Yeah, and then we go collectors collect to set. Again, is it readable? No, somewhat, right? Does it perform well? See, we are creating a stream here again. One could say, okay, maybe we should shift this map and put it like here to this NS stream. But then we would map all the words, right? Even the ones we don't need later. So this is also wasteful, right? There are these ways, right? So this is not perfect because we create another stream, or we could map all these elements, right? Or we could perhaps decorate all these elements. Why? Let's say we are like Java 16 all words, so we create like a string wrapper as a record, right? And we change the equals method, so then it works with a distinct. Again, is it easy to read? Is it maintainable? Not really, right? Or we have another fancy and pro solution, and I'm pretty sure we will end up with like good old for loop, right? Or while loop, yes, again. Is that readable? What the whole purpose of streams was to be like a declarative, right? Nice for data processing, so maybe this is not a good approach. And what we could also do, we could go like for OpenJDK issue tracker, and we could say, please add stream.distinctby, okay? And they could have added this method. Right? Thankfully, they didn't, because there is like half a dozen, or at least 3 more dozen of real, actual business needs, just like this, from people all around the world, right? And if they added such methods, I mean, these are really nice methods, but they would clutter the API, okay? This would make the whole bloated class even more bloated, right? Fun with maintaining, right? Good luck, right? Okay. Yes, if only there was something we could use. Something just like collectors in the middle of the stream. And here we get to the what part, which is plugins. Are you familiar with plugins? Add-ons, something like this, right? And actually, if you think about this, collectors are like implementing the design pattern of plugins, right? You just create your own designer, sorry, not designer, collector, you put it in this place, right? And it plugs in the whole processing, the whole machinery, right? So this is how it works. So now enter stream gatherers. Preview features Java 22, 23, and the standard feature in Java 24. I encourage you to go and read this, right? It's very interesting to read these documents, right? Basically, who's the friend with this Spanish guy named Manuel? Be friends with Manuel, okay? RTFM. Okay, you're friends with Manuel? Very nice. Someone finally reads the documentation. Like, please come back later. Okay, cool. Very nice. Okay, and there's also another thing because someone said Gen AI, right? There's like, yeah, okay, cool. Yeah, Gen AI. What are stream gatherers in Java? The stream gatherers in Java refer to techniques and tools for blah, 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 and this is what it says. Nah, wrong answer. No, seriously, I've taken this screenshot like some time ago, right? So if you go without search, this is pretty much the answer you get. If you go with search, it will find out that there's like stream gatherers and there's something else in there, right? And this is how we might want to create RAG. I have another talk about RAGs, which I'll be giving tomorrow at GeekCon in Poland. Anyway, too long, didn't read. This is the API. The whole fast is actually about just one method, gather. Okay, there's also another method. If you're more of a Haskell gang, who's Haskell? Nobody. Okay, so we can go gather and then if you want to chain many of them, right? So what these stream gatherers can, they can transform elements, right? They can take any number of elements and put them into any other number of elements, right? So this is actually like, this is the universal case. So it can take like 0, 1, 17, and then push downwards, I don't know, 0, 17, 122. They can't put, of course, like a negative number, right? They can suspend elements, which means they can accumulate, and then release them in one batch, right? They can short circuit, meaning turn infinite streams into finite ones. They can track, of course, already processed elements. They can keep state between executions. Not sure these last two are wise to employ, but technically they're doable, right? And they also, of course, enable parallel execution. Let's get to the meaty part, the how. So let's try again. If you take a look at this code, is it somewhat more readable than the one with collectors? The opinions are divided. Very good, right? We shouldn't trust everything that's just put on the screen. And this is how we can implement this gatherer, right? So we can just have this supplier, which will supply us the hash set of type integer, right? And then what we do is like we check if our state already contains the length of the element we're currently processing, right? If not, then we will add this length and we will push this element downwards and we will like return true, which is give me more, right? And this is basically it. If we want to like have this as a class. What we can also do is something like this. See, we can go gather of sequential, right? And we can have this supplier for the initial state, an integrator, which is kind of like the engine of this whole thing. Then we have map here, and please notice that here we're mapping only the elements that we are about to return, right? Nothing more, nothing less. And then, of course, I'm returning an unmodifiable set. And this is how this integrator looks like. So this is basically, see this part, right, of this previous gatherer interface. Maybe let's go into the code, because the code seems to be more trustworthy. Let's go with this gatherer first, perhaps, right? So we have something like this. Let me rerun this. See, we got the same results because we don't go like this up state, right? So this is what I have just shown you. And if we go here for this gatherer and up and rerun, see, then of course this is this unique by length gatherer, which is basically this. And this is what you can put into your gatherers package, right? Hopefully not utils package. I can also like enable this thing, and there you can see it will tell us like what elements it was skipping, right? Don't debug like this. This is demo only, okay? Demo only, please. And this is just to give you an impression why sometimes not always true, because let's say we can be done after 3. But then I would say we've collected 3, right? And we're done with processing. That's why it doesn't even say skipping this or skipping that. Question, what is the bug in this code? Nobody? Not, I'm afraid, no. The requirement was make them all lowercase, and we made them all uppercase, right? But who cares? I mean, uppercase, lowercase, pfft. Sorry. See, we didn't read the requirements. Anyway, so this works, right? So the formal definition of a stream gatherer is the following, and I hate it. That's why I prefer this one. You see, they say a few things about Java, right? What they say about Java. Java is, okay, Java is awesome, like, okay. Java's awesome, what else? Java's slow, Java's dying, Java's verbose, right? So if Java is already verbose, why not add some more verbosity to it, right? I would say this is perhaps more readable. Fun fact, if you have generics, you don't have to stick to one character, people. Okay? I dare to say this is more readable. All right, so we have the state or type of the elements we're taking in, the type of elements we are pushing out, and the type of our state, right? And suddenly, I hope this gets easier to read, right? So we have initializer, integrator, combiner, and finisher, and please see that only the integrator here, this guy, is not default, which means you need to always provide your own integrator. For everything else, we can go with defaults, all right? So how do we construct these gatherers on site? We can go for a sequential, just having the integrator. I call it like the engine, right? Of the, like if you have a car, and it's not like a car for streets, but let's say racing, maybe you can forget even about brakes, right? But you can't forget about engine. So there's integrator and finisher as well, or initializer, or we can have all 3 of them. And because it's sequential, it won't have this combiner, right? Which shows up here, because then it means this gatherer can be run in parallel, so we need combiner to combine 2 parallel like executions, right? Right, and there can also be like finisher and so on. We'll get to all of these. So the integrator, right, the engine, it takes the current state, the element we are processing, and it has the downstream, right, which is like for this sort of like, I'm afraid, side effects, pushing stuff down, right, as the name implies. So it consumes this next element, may or may not inspect the current state, right? In many cases, it can just ignore it. Like, let's say you're implementing just a map, right? You don't need a state for a map, okay? Can send any number of items downstream, okay? Can return true, as we've seen, like for give me more, and we can also go for greedy if we can like signal it's not going to shortcut ever. There's a combiner, right? Basically combines 2, parallelizable gatherers. English is not my mother tongue. And there's also finisher, which can still operate on downstream. I'll show that in one example. And there's downstream, which, as the name implies, can push things down the stream, right? What else? This is like an example of good naming, people, right? Do you know, I mean, this is like an evergreen. Do you know the 2 biggest issues in computer science? Naming, cache invalidation, and off-by-one errors. Yes, we also have built-in gatherers. A few of them are built-in. So no Haskell people, Scala people. Okay, so you know what? We have a nice cluster of Scala people over there. All 3 of them. Welcome. You're always welcome. Yes, so we can have like a fold, scan, window fixed, window sliding, and also like map concurrent. Maybe I could show you how they work in here. I have this, here, built in. Okay, so let me run this code first. See, it runs. It's usually good when the code runs, don't you think? Yes, so we have the folding. And what I do here, and maybe it will be seen in this lovely editor, see, this is the same lambda. So this is the same thing I want to do with my elements, right? But as you can see, the result from folding and scanning here is different, right? This is what we have for folding, and this is what we have for scanning. So folding, basically, it means it will like turn all the elements into a single element, right? And I decided just to concatenate the numbers, so therefore my initial state is an empty string, right? So an empty string, I'm adding 0, 1, 2 as characters, right? Then I have scanning, which is basically sort of like, this was my, so initially I have nothing, right, empty string, and then I'm just sort of like prefixing with what it was before. So 0 got prefixed with empty string, then 1 got prefixed with string having character 0, and so the story goes. That's why we have 9 elements, okay? Now, so this was for functional programming people. Do we have any SQL people in the room? Come on, don't lie to me. There are many SQL people, they just like, no, I'm not a SQL person, I mind you. Okay. No, I'm pretty sure we have like a pretty few SQL people. Do you know this, this is also like an evergreen, this windowing issue of SQL? Yeah, so we can have window fixed or window sliding, and this is it, right? You can see it in action. So we create a window of fixed, if you have like a 0 to 9, right? When we create fixed window, we have 0, 1, 2, then 3, 4, 5, and so on, and up until we use the very last element, and it's like 9 because it has no companions, right? Or we can have this sliding window, and then it just, as the name implies, slides. Right, so you see the results here, it's just sliding by one element, so we can combine them, and these are the lists, right? So yes, these are the 4 build ones. Let's go for an epilogue, right? Time for an epilogue. Who is using streams in places where performance is really important? Brave souls. Yes. So the other ones aren't using, I mean, because I have asked you and you, like there was like a whole forest of hands, I would say, of people using streams, right? So I guess we have like some hesitation towards it, right? And that's maybe the issue. So do you remember what Java 8 was a thing, 4,000 years ago? And everyone was like, yeah, we'll just toss dot parallel and we'll like reveal or use all the power from the computational power. It's just one method call and yeah, it'd be awesome. It wasn't, right? For like a few reasons. Again, I'm missing this like a brilliant math friend. Let's say I have this call, this method. Actually, let me go for the code. And I hope I didn't mess this up, or maybe I did. Of course I did. Never mind. Okay, so we have this something. This is the implementation of concurrent mapping, or this like enriched, right? Kind of like think about this thing. I have 100 elements, okay, and I have this method which is slow to double. It just doubles the number only slowly. It takes 1 second to double. Okay, now the question is, how long will this whole thing run? I guess longer than Gunnar's implementation of like 1 billion threads, like a rows or something. Any guesses, how long will it take? Can I get 5 seconds? Can I get 7 seconds? 1.5? 3? Don't be shy, it's time for fun. 15. 1. 26, someone said. There is one correct answer, I'm afraid. It depends. But if someone asks you, as it tells you it depends, then you obviously, like, how do you tell an expert? Because like, these self-made people, they will, oh, it depends, and you feel gaslighting, right? The real expert will tell you it depends on. And what's the on thing here? Yeah, like a CPU, like a size or common ForkJoin pool, right, and so on. Exactly. So let me go here and just htop. So as you can see, I have 12 logical cores, right? And let's assume nothing else is running right now. So I have no noisy netbus. So how long will it take? Sorry? 4? Why 4? Okay, let's just skip it. Okay, let's just run it. Sorry, I've run the wrong demo. Sorry, it's on me. So, time for a quick joke. How many ears did Captain Kirk have? 3. Left ear, right ear, and the final front ear. I brought it from Colorado, people. It's a good joke. 9 seconds. Why 9 seconds? Because 100 elements, each taking 1 second, so they divide it into batches of 12, right? So I have 12 times 8, that's 96, plus remaining 4 elements is the 9th second, okay? Perhaps we can do something about this, and the thing would be this, using gatherers map concurrent. By the way, just so we make it clear, it was never a good idea to use Java's streams for like side effects, operations, using like HTTP calls, like data enrichment this way, okay? And I think it still doesn't. I mean, it's still not a good idea. But now let's say I'm using this map concurrent thingy. And why map concurrent thingy, right? We've established, okay, just one more question. How long would this take if I decided to go this approach? Huh? Roughly twice as long, right? So there is this thing, and I even asked like Victor Klank, who's the main author of this JEP, right, for stream gatherers, why isn't this thing advertised properly, right? So now it's like me, I have to annoy you about this thing, which is map concurrent. Like I like it so much, I even wrote. I don't think I ever wrote a blog post about a single API call, right? And I wrote it because I think it might be like really, really useful, right? So now if we do something like this, right? And as you can see, oopsies, I'm just switching between the lines, right? So I'm going this, and I'm using map concurrency, and it's the same tools, slow to double. How long will it take now? 1 second, someone said. Let's see. You were right. Who are you? Yes, I'll put a swag for you, okay? This lovely elastic webcam blocker. It's really nice because it's like bends, it's flexible. Elastic, right? Yes. Yeah, 1 second. Of course, it's a little bit cheating, right? Because this slow to double is doing, see, demo only please, thread sleep. So this is a good candidate to be run in parallel by stream gatherers, right? But of course, like they can be many more. In short, if this method is slow because it's CPU bound, going map concurrently won't give you anything. But if it's blocking due to other reasons, right? When virtual parts, threads can be like unmount and then mounted again, maybe it can be useful. But again, like streams, third side, like side effects, maybe no bueno. Right? Why is it still like kicking here? Sorry. Yeah, so we established 1 second. Okay, I guess we have time for more demos. Very, very fortunate. I have more demos here. Okay, so let's go for palindrome. Do you know what a palindrome is? Do you know what's palindrome of Ipswich? Does anyone have a dead parrot? Okay, I've learned what a palindrome is at the university, and then I ended up watching, what was it called? Monty Python, the Dead Parrot sketch. Really nice one, crème de la crème. Okay, now we'll be dealing with other sets of words, right? So I have diamond, jacket, race car, sherry, dolphin, and so on, and ends with radar, okay? And the task is the following. We need to find the palindromes okay, among these words. So what we can do, first I'm mapping all of them to lowercase, right? Then I'm creating a sequential gatherer, which is this one. And as you can see, I'm ignoring my current state. What I'm just doing is I'm pushing downwards elements we have replaced all whitespace characters with nothing, right? And so basically this could have been a map call, which shows us that if we had only gather method, we don't need anything else, map, filter, whatever. Gather method could be, in theory, the only intermediate method in streams, right? Then we have filter is palindrome, and palindrome is, fun fact, if you reverse the word, it's still the same, right? Then it's a palindrome. Right, and then, right, as you can see now, I can use this unique by length gatherer again. So I can map, gather, filter, gather, do whatever. It's just like a good intermediate operation. Right, let me run it, and these are the palindromes we have, right? Again, when they are unique by length, right? So we have race car without space, kayak, noon, and so on. Doesn't make sense? Okay? I don't know what's the meaning of life, but I can try to answer like any other questions, okay? Now, let's go for pairs, okay? Some say that Java doesn't have tuples. And the answer is, in German, this is a good answer, jein. Haben wir hier jemanden aus Deutschland? Okay, okay. Außer Gunnar? Nobody. Yeah, so the jein is like yes and no together at the same time, kind of like a Schrödinger's answer, sort of this. Am I explaining this correctly? More or less, yes. Jein, okay. See? Very nice. This is it. Maybe we should have this in standard API, I don't know, but this is how much it takes you these days to create like a tuple of two, right, a pair of any type. Anyway, I want to combine these elements into pairs, all right? This is it. Right, this is, let me make this smaller and maybe, okay, maybe I should have added in like a line break here, right? So what we do here is this. This array list is our accumulator, right? And I have this integrator of a state element in downstream. And if our state is empty, we consume the element and add it to our sort of like a intermediate state or internal state, right? If the state is not empty, what we do, we push a pair, which is the previous element, right, and the current element. Fun fact, since Java 21, you can get first on sequences, right? And then we empty the state, which is remove first, and we return true, and so the story goes, right? And here, what you see in action is this finisher. I was told once, I don't know if it's true, that in France, when you invite people to a party, all right, and 13 guests show up, this is like terrible, because it's like bad luck and so on. So actually, we can call an agency, and they will send a 14th guest. Okay, so this is like, let's say, let's do it this. If we finished processing all the elements and our state is not empty, which means we have an element there, we can like, okay, this is the like, so you're not alone, okay? Like our artificial element, right? Let me run it here, and let's see if it works. See, yes, we have these pairs, right? So it's diamond, jacket, and so on, and we have at the end radar and our single, right? So radar is no longer single, okay? So this is the purpose of finisher, right? To finish with unfinished business, sort of, in this whole process of gathering, okay? Next thing is like length fluctuations, okay? Like, shameless plug, if you're into observability, then of course like Elastic Stack would be probably better, but let's say we need to detect these fluctuations. Let's say we have a sudden spike of CPU usage or sudden drop, right? So, and our autoscaler didn't scale down properly. Or you're monitoring in temperature, and when the temperature raises slowly, like 1 degree by 1 degree, let's say every 10 minutes, it's okay. If you see sudden increase, it might have been a Chernobyl, okay? So you want to know about this. So this is like this fluctuation. And in our example is this. If the length of 2 consecutive strings, it differs by 0 on 1 characters, it's okay. If it's more than 1 character, it's a fluctuation, and we want to be notified about this. I don't know. We need to like be paged, right? A text message, email sent. I don't know, big sirens, you know, making a lot of noise or whatever. Here I'm just printing it to the standard output, right? So what does it do? See, I'm calculating the absolute, right, difference of the length of the first element and the length of the second element. Because what this thing does, as you can see, window sliding creates me a list of, a stream of lists of strings. And because it's 2 here, we'll have like only 2 elements per each, right? So let's run this code and see these are the anomalies. So between noon and redder, there are 2 characters, right? So it's fluctuation. So as you can see, this is what you can use gatherers, oopsies, for these days too, right? And there are more uses. And there's let me just go for another example, which should be, because I was searching for like more real life example, right? And again, timer, like for a shameless pun, right? And when it's about search, right, usually the good candidate is, yes, you know it, Elasticsearch, yes. So there are many reasons why Elasticsearch might be a good candidate. One of them is that unlike, let's say, the SQL, I just saw it when I was reading a book about Elasticsearch, right? One of the reasons is that fields can be kept in multiple times at the same time. It's not like live, like a live conversion or real-time conversion. It's just when you put data inside Elasticsearch, you can already say, okay, I want to have this field in this type and this type and that type, right? And one of the types is called ngram. Very good, very fortunate that we have you here, Gunnar. Sorry, like this couldn't have been better. Okay, so we have this thing called ngram, right, tokenizer. And do you know this situation when you type 1 or 2 or 3 characters, or let's say in e-commerce store, and it gives you a drop-down with all the options, and sometimes the character in front, the middle? Yes. I mean, maybe not so useful in Bulgarian, maybe not so useful in Polish, but really, really useful in German when you want to search, for example, for Heckscheibenwaschanlage. Okay, which is like rear window sprinkler, if I'm not mistaken. Yeah, Gunnar says like, okay. Sorry for butchering German. Yeah. So see, especially for languages like German, even if it says so here, like German, ngram tokenizers are nice. And what does it do? Let me just run real quick for you. So this is like without any additional parameters, right? When you tokenize as ngram this quick fox, it gives you the following, like Q, QU, U, then we go for UI, and so on and so on. If we change the parameters to be like minimum length 3 and maximum 4, for ABC, you get ABC, ABCD, BCD, BCDE, and the last one should be CDE, right? So it's like 3, 4, 3, 4, and so the story goes, right? Because you don't know how many, like, what would be your minimum to show in this drop-down, right? When people want to search. And this is especially important, for example, for all kinds of e-commerce or selling, because you don't really know what people are going to look for, right? Anyways, it's now not that I urge you to re-implement Elasticsearch. I mean, these sources are open source again, right? So there is no need for this, I guess. But let's say, let me first run it with the test. So I should have this test here, which is like, yes, this ngram test. Let's make sure if it runs and passes. Yeah, passing tests are the best tests, I would say. Yes. Yeah, so if we have A, B, C, and 3 and 5, we expect an exception because it should be like a difference maximum by 1. If we go A, B, C, D, and 3 and 3, we expect A, B, C, B, C, D, and C, D, E. And this is our example, right? So if I'm running A over this string, right, A, B, C, D, E, with minimum length of 3 and maximum 4, this is exactly what I expect. These are my ngrams, right? Now, let's try to implement this using this ngram gatherer. So what actually happens here, right? Of course, I have like a constructor, right? These 2 fields. I check the invariant, so the length is correct and given and not negative and stuff. And my initializer for my internal state is going to be like string builder constructor, right? So my internal state will be string builder. And now, let me run this experiment Gedankenexperiment, sorry. Yes. And this is our integrator. Remember the engine, right? So we have received the element. We append this element to a state. If we are processing A, we just append A to an empty string, right? Sorry. And then, is it the minimum length of 3? No. So we don't go here. Is it the length of 4? No. So we just continue processing with true. And so we process with B, and so we process with C. And now, finally, we have ABC in our accumulator, right? Temporary state. And so what we do, we push downstream ABC, the string of ABC, right? And then we jump here. Is it 4? No. So we continue. Here we put ABCD. Right? So what we push down, A, B, C, D, and was it the length of 4? Yes. So we remove the first character, which was A, and we push here, as you can see, B, C, D. And so the story goes. So as you can see, I received like one element, or 5 elements, which is like A, B, C, D, right? 5 characters, and I'm pushing like not always, sometimes in batches. So this is like, it shows you that stream gatherers allow you like, you don't have to state for like one-to-one or one-to-many, right? You can map the elements however you wish, right? Yeah, this is the finisher. It doesn't do anything, as you can see. And isn't it beautiful? Doing nothing these days in Java. You don't have to go for this underscore ignored or whatever. Just underscore, like totally nothing, right? Yes, sorry, I couldn't resist with this one. Okay, I would say this is it. Okay, one more thing, just before I forget. See, this is running on, sorry, Gunnar, one last German joke, okay? One last. This is running on localhost, or as some people in Germany say, localhorst. And if you want to know how to run it, you go like elastic start local. You open this link, right? And if you have Docker running and internet running, then you can just go this thing, and this will allow you to run Elasticsearch and Kibana like on your machine, like a premium license. This is not production use. This is like evaluation purposes only, right? Okay, cool. So please remember, always, every conference, every meetup, every talk, right, whether the guy is from Poland or from Germany or God knows where, please provide the speaker your feedback and the organizers, right? So I don't know, sorry, how JPrime does it. Do you have an app? There's like a survey after the event. Please let people know, right? If you prefer to let me know, like sort of like privately or anonymously, I don't know who you are, so please fill this survey. If you're watching this on YouTube, right, there are 2 things you should do. First, hit the subscribe button, right? It's not going to be my channel, right? It's going to be JPrime's, okay? And the bell, maybe, I don't know. And then you can also fill this survey, even if you're watching this on YouTube. The link is somewhere, I don't know how they compile this, somewhere over there. If you fancy to follow me on social media, I'm on Xeter, Blue Sky, Mastodon, LinkedIn. No Instagram, sorry, no Insta. I'm one of the boomers, right? These are the slides. If you want to have the slides, the code and everything, this is the link. The link, sorry. In 3, 2, 1. Yeah, you take picture of this. I might want to take a picture with you in the meantime. How do you say cheese in Bulgarian? Okay, just say whatever you please. Okay, just so my boss knows I'm not slacking, sorry. Yes, this was Mnogo Bogadorodya. I shall be around for like 1 hour or so we can ask me questions about Elastic. If you want to run Elastic meetup at your company or whatever, please don't forget to get some swags, right? These are free, and the lucky winners, please come to the desk. Thank you.